Right? We had seen that there are certain
Yes.
physical quantities which are vectors, which need directions along with their magnitude, and they are represented, they can be represented geometrically with an arrow. So the length of the arrow represents the magnitude, and the direction of the arrow points in the direction of the vectors.
Yes.
You know, depending on the properties of vectors, we divide vectors into two broad categories. Vectors are either divided as axial vectors, or they are known as polar vectors. So today's class is on vectors, and we say that vectors are physical quantities having magnitude as well as direction.
Yes.
They are the physical quantities having magnitude as well as direction. They are called as vectors. Now, so we have divided vectors as polar vectors and axial vectors. So the polar vectors, if we want to know what are the polar vectors are the vectors which they act from the point of application in the direction of in the direction in which they are acting. So polar vectors, they act from the point of application point of application to their directions. So wherever they have their directions, they act from their point of application. So they are polar vectors. In the similar way, you have axial vectors. So as the name suggests, axial vectors will be the vectors these are the vectors which act along the axis.
Yes.
Vectors that act along an axis. They are called as axial vectors. So such axial vectors, they do not have their point of application. Their point of application, they may be different from wherever we are guessing. But axial vectors, they will be acting along the axis. And if we define an axis, so an axis may be in terms of rotation. Generally, if an object is rotating or revolving, so it rotates or revolves around an axis.
Yes.
So such vectors are generally found in the case of rotational motion. When we have rotational motion, then we observe axial vectors. For example, we observe the rotation of a top. So in the case of rotation of top, we observe that top rotates. In the case of rotation of top, the top rotates about a fixed axis, and that
So what is
axis
top, sir?
top that two. There,
Acha, okay.
okay. So I can show you that I hope you have understood what's the top.
Yeah. Yes, sir.
Okay. So in that rotation, or even if you have any object rotating, Earth is also rotating. So there is an axis of rotation, right? Which we say that the axis of rotation is tilted by an angle of 23.5 degrees. Right? The axis of rotation of the Earth is tilted. So that is the axis of rotation. So here there are certain vectors which act along the axis of rotation. They are called as axial vectors. Examples of the axial vectors, if you see,
It can be a fan.
yes,
Can it be a fan also?
uh, yeah, fan is an example of rotational motion, but it's not a vector. In terms of vector, I can say the angular displacement.
Okay. Okay. Yes.
angular displacement, angular velocity, okay, angular acceleration. So all these are axial vectors, right?
Axial vectors.
So how where in what direction do they act? Let's see. If an object is moving in a circle, so here we observe an object moving in a circle. Here we have taken a circle, and let's say the object moves over here in this circle. Now I think it's better understood that if an object starts moving in the circle, suppose from here, let this be the starting point, and from this starting point, the object starts moving in the anti-clockwise direction. So there are two sense of rotation which are possible for this object. Either it can move in the anti-clockwise direction or it can move in the clockwise direction, right? These are the
Yes,
only possible sense of rotation. So suppose it covers a certain angle theta. Here, during the rotational motion, if it covers a certain angle theta here, so we observe that it is moving in the anti-clockwise direction. This is the starting point A, and this is the final point B. So it has
yes,
made some angular displacement. As we know that displacement is a vector quantity, so angular displacement is also a vector quantity, but the direction of angular displacement will not be like this along the circle. It will not be along the circle. The direction of angular displacement is along an axis passing through the center. So if you make an axis passing through the center and perpendicular to the plane. So here we have this axis. Now, so angular displacement is considered along this axis. We consider the angular displacement to be acting along the axis. So as we know that above this we have the positive axis and below this we have the negative axis. If the sense
right.
of rotation is anti-clockwise, we take the angular displacement to be positive. That means along the positive axis. And if the angular displacement is negative, it is moving in the clockwise direction. We consider its displacement along the negative direction. We
Yes,
consider
sir.
the angular displacement to be negative, moving downward. So actually, this ring or whatever disk is there, it's not moving in the downward direction. It's not moving in the upward direction. But the angular displacement will be taken along the positive direction and negative direction. Got it? In the similar way, we can take angular velocity also. As we know that angular velocity denoted by symbol omega is given by theta by t. So the
Yes, sir.
direction of, since we know that velocity is also a vector quantity. So the angular velocity is also a vector quantity, and the direction of angular velocity will be acting along the positive x-axis. If or positive axis along again along the same axis only. It will act along the same axis, but if it is moving in the anti-clockwise direction, we will take
It
the
is
angular
positive.
velocity to positive, and if it's moving in the clockwise direction, we will take it negative. Okay. Similarly, similar to this, you have angular momentum. We have angular momentum. We have studied about the linear momentum. Just similar to this, you have angular momentum also. Then rotational force, we call torque. So all
Yes, sir.
these, they are axial vectors. So I hope you have understood about the polar and axial vectors. As an example of polar vector, if I give you any example of polar vector, so for the polar vectors are the vectors which act from the point of application to their direction. For example, the displacement that we study, linear displacement. Okay. So linear displacement is a,
Like a car moving in a certain direction.
yeah. So you have
Okay.
linear displacement, linear velocity, they are polar vectors.
Yes, sir.
Linear velocity, it's linear acceleration, force, all these are polar vectors. the representation remains the same. The representation of the vector is represented with the arrow.
Yes.
So they can be represented with symbols. So as you know that vectors, they have a direction, and hence if you have to add two vectors, if you have to subtract two vectors, so our rules of algebra do not work there. Okay. So Dhananjay, I hope you will pay attention. Just we have discussed about polar vectors and axial vectors. So yeah, we were discussing about addition of vectors, addition and subtraction of vectors. So let us first see addition of vectors. Is it the same way? Can we add them algebraically as we do the normal additions? Can we add the vectors like that? The answer is no. We cannot add
No.
them as they are direction dependent. Their magnitudes, their quantities, they differ on the depending on the direction. So here I'll consider an example. So let's say, so let us say for addition of vectors, I take here, suppose we have a, this is an object and let it be subjected to a number of forces. So let us say it is subjected to a force over here. It is subjected to another force here and it's subjected to another force here. So there are three equal forces, F1 or let's say F1, F2 and F3. Now there are these three equal forces. Let's say they are acting like this, F1, F2 acting like this and F3 acting like this. So that how can I obtain the resultant? How will I be able to guess the resultant acceleration? How should I get that what is the net force acting on this object? As we know that the net force is equal to mass times acceleration. So how do I decide that what should be the net force? How do I decide that what should be the net displacement? For example, if I do the same thing with the displacement, so just considering an example for displacement here. Okay. So we have our y-axis here, we have x-axis, and now let's consider the displacement of an object from this point to another point here. Okay. So how will I be able to get the displacement in the specific direction over there? Okay. So the region, what should be the net displacement? If this is the first displacement, after this the object moves here. So what should be the net displacement that I want to find out? So again, to find out the net displacement, there are two displacements. Okay. We can see this one is the first displacement. This one is your second displacement. And if you join them, let this, so this is your final displacement. Okay.
Yes.
This is your displacement 1, displacement 2. This is your final displacement, displacement 3. So how can I find the net displacement if I know the initial two displacements? So the answer is simply you have to add these two. If you have to add S1 plus S2, or it should be equal to the final displacement S3. Okay. But do they obey? Can I
No, sir, it
obtain
will
this
not.
algebraically? Algebraically, will I get S1 plus S2 equal to S3?
No, sir.
The answer is no. I cannot get. Okay. So we have defined a certain set of rules for addition of vectors. Okay. So let's see how the vectors are added. So here to add the vectors are added algebraically, vectorially using laws of vector addition. And the laws of vector addition, there are two laws of vector additions. We call them as the triangle law of vector addition.
Just like for the previous example.
Yeah. So we have the triangle law of vector addition. And we have parallelogram law of vector addition.
Yes.
So in this way, we can find out the net vector acting at an object. So in the parallelogram law of vector addition, we will see how do we find out. So let's see, first of all, we will see the triangle law of vector addition. How can we add two vectors using the triangle law of vector addition? So let's make here, we consider here two triangles. We consider here two vectors. Let us say you have a vector A. So you have a vector A represented like this, and you have another vector B. So let's say you have another vector B. And I want to find out the net resultant. What is the resultant of these two vectors? You have a vector A, you have vector B, and now I want to find out what is the resultant of these two vectors. Resultant means if I add these two vectors, what will I get? So these two vectors can be two displacements, they can be two forces, they can be two velocities. Are you getting? When I say
Yes, sir.
vectors, they can be, it is applied to all the vector quantities. Okay. So to add them, we have to make them either co-initial. Okay. If you are using the triangle of vector addition, so using the triangle of vector addition, vectors can be added. First of all, they have to be arranged in order. Arranged in order. So first of all, I'll write with to avoid any confusion, I'll give you the statement of the triangle of vector addition. As per the triangle of vector addition, if two vectors are represented in magnitude and direction, by the two sides of a triangle, taken in order, then the closing side, I'll explain everything. So then the closing side represents the resultant. Then the closing side represents the resultant both in magnitude and direction. So we'll try to understand this. So let's see, what does it mean? It simply means that I have these two vectors and now I want to add them. So first point is that I have to put them in order. In order means I have to put the vectors in such a way that head of one vector joins with the tail of the other vector. So there are two ways of joining. Either I take out this B and put it here parallel to this.
Yes.
If I move this B parallel to it like this, so I find that the two vectors are now in order, right? Can you see here that the two vectors are now in order? The tail of one vector is acting as the head of the other vector. It is attached to the head of the other vector. And now if I close this, if I close the third side to form the triangle. So now I close the third side. So this is our third side. I close the, and making the third side. So third side or the closing side, it represents the resultant both in magnitude and direction taken in opposite order. So its order has to be taken opposite. Opposite means here I am going from this is the tail of one arrow. This is the head of that. So this is tail. This one is head. So how I am moving? Tail, head, again tail, head. Okay. So here at the third one, if I'm moving in the same order, so here it should be again tail and then head. I have to take the opposite order. Opposite order means I have to make here head and this one as the tail. This is the opposite order. If you are
Okay.
moving in the cyclic order, so you will come across like this: tail, head, again tail, head, then again it should be tail, head. So the last one you have to reverse the order. Okay, it has to be tail, head, then it has to be head, tail. Then only it represents the resultant taken in opposite order.
Yes.
So Dhananjay and Jaswant, have you understood? Because you people joined quite late. So see here we are representing the, I hope you have understood how to find out the resultant of these two vectors. Now our target is, since it represents the resultant, this line, the yellow line, it represents the resultant both in magnitude and direction. So that means if I find out the length of r, so the length of r will be the magnitude of the resultant vector. It will be the resultant displacement, it will be the resultant velocity, it will be the resultant force. Okay. And
Yes.
if I find out its direction, direction means it's theta that it forms with the other vector. If I able to find out this theta, so then I can find out the direction of the resultant vector. I can say that the resultant vector is making an angle theta with the a vector.
Yes.
So Dhananjay, have you understood? Just one. Dhananjay and just one. Are you there? Yeah. Okay. Just one here he has understood. Dhananjay also says yes. So see, I'm giving you a fresh example and we will again try to use the triangle law of vector addition and see where is the resultant vector. Okay. So if you have suppose a vector A, I give you a vector B acting like this. So these are the two vectors. You have vector A and vector B. Now if I have to find the resultant, then I must put them in order. Okay. So to put them in order, I should move this vector parallel to itself and combine its in order, combine it with the other vector in order like this. So see, I have moved it parallel and see. Now can you see the closing side?
Yeah. Yeah. Yes.
Okay. So as now we can form a triangle by a closing side. So let me write the name of the vectors. Your vector A, this is your vector B, and the closing side will be represented by the third side. So this is our third side. It represents the resultant vector. Now, what should be the direction of resultant vector? Should it be from bottom to top or top to bottom?
Top to bottom.
It should be from top to bottom. That means we have to take it in opposite order. So this line represents our representer. Okay. It represents our resultant.
Yes.
Now let us see how to find out this. If I have to find out this one, so how to find out this? That we call as, so complete detail, how we find out this. That we'll be doing in our full-fledged class. When we have our full-fledged class, so then we'll deal, yes, how we can find out this. Currently, I'll just tell you the formula, how this resultant is calculated. Okay.
Okay. Sir.
So currently, I just tell you the formula of this resultant. The resultant is taken as, resultant means the length of this resultant. So I also put it as vector r and the two lines which represent the magnitude of the vector r. So it is, the vector r would be equal to under root of magnitude of a vector. So if I just write a, it is understood that I'm talking of magnitude. So a square plus b square plus 2ab cos theta, where theta is the angle between the vectors a and b. Here, theta is angle between a and b, which we know. The angle
Yes.
between two vectors is the angle when the vectors are placed co-initially. If you place the vectors co-initially, so whatever angle is found between them, that will be their angle. So if I talk for this one, so for this one, the angle that acts between them should be this. I'm making them co-initial. See, it was like this, and just to find out the angle. So if it were here, okay, if it were here, so it would become co-initial, and hence this angle would what be the theta. So this angle would be the theta angle between the two vectors, and I draw here my b.
Sir, how is the, what do you mean by,
Co-initial.
yes, sir.
Okay, uh, co-initial means when the two vectors are arising from a common point, like this. So if you have a vector
Okay.
a and vector b, so the angle between these two vectors will be this angle. This is the angle between them. Now, if
So,
you
sir,
have
the previous triangle, sir, what will be the theta?
here,
The previous one.
here,
Huh.
okay. So here I have to make them co-initial, and I can make them co-initial just either if I move this b parallel to itself down. So you can see then the value of theta would be this downward direction theta. Let me show you. So if you take this over here, okay, it's moving. Yeah. So if you take it here, so can you observe what's the theta? The angle between A and B. Are you getting the complete angle?
Yes, sir, yes, sir.
Yes. Now, the only we can get it directly from here. Whatever angle is this? Suppose this is some angle. So you subtract this angle from 180. This will be the angle between the two vectors.
Okay, sir.
Okay. So the magnitude of the resultant is given by theta r equals under root of a square plus 2ab b square plus 2ab plus cos theta. Okay, so this is the magnitude. The direction, I will also discuss about how to give the direction, but let's do one small question with this, how we can find out the magnitudes. So you have two forces acting. Okay, in your maths class, how many of you are attending your maths class also?
Sir, I have not taken maths.
No, you have not taken maths, but you should be attending those
Sir,
maths classes.
I'm attending.
See, the reason being that we are currently discussing the basic maths which is being applied to physics.
Sir, you mean the differentiation and all that, sir?
Yeah, the differentiation,
That I
integration.
have learned, sir.
Okay. So trigonometry, all these tools.
Yeah, yeah, yes, sir.
Okay. So or two forces of magnitudes 20 Newton and 30 Newton act at an angle of 120 degree. So find find the magnitude and direction find the magnitude and direction of resultant. So all of you can find out the magnitude.
Yes.
Yeah. Do I need to show the formula again?
I got it.
Dhananjay, just one.
Got it, sir.
Okay. So the formula is to be used is R equals under root of A squared plus B squared plus 2AB cos theta. So the two vectors are given. I can put the value of R as under root of 20 squared plus 30 squared plus 2 times of 20 times 30 times cos 120.
So cos 120 will be minus 1 by 2.
Yeah, it is minus 1 by 2.
Okay, sir.
So you get here value as 400 plus 900 minus 600. If you put value of cos 120, cos 120 is minus 1 by 2 and minus 1 by 2 multiply with this is 600. So this we get our answer under root of 700. So this is 10 root 7 Newton. We have got the resultant.
Yes, sir.
Okay. Now how do we find out the direction? So see, to find out the direction, you have to make these vectors. So make the vectors here. You see, we make this vector. We make the two vectors acting at an angle of 120 degree. So the two vectors, they are acting at an angle of 120 degree. So here they act at 120 degree. This one is 30 Newton and this one is 20 Newton. So which side will be the resultant side? Can I complete the triangle?
No, sir, it's not complete.
Yeah. So to complete the triangle, I must make them in order. And to make them in order, I have to move one of the vectors parallel to itself so that I can apply the triangle of vector addition. And for that, I can make this 20, either I can make this move 20 Newton over here, or I can make this 30 Newton move on the upside. So if I move this 20 Newton here, I can see the vectors now, they are in order. The two vectors, they are in order. And here, as we know, theta, we already know what is the angle between them. So for simplicity, I'll just mention it once more, what all angle values are here. So this is our 30, this is 20 Newton. So this angle should be 60 degree. Here it
Yes.
should be 120. Okay. Now the closing side, I get the closing side as this side as the closing side, which should be the resultant. So here this one is the closing side and its direction is to be taken in opposite order. So like this. This one is the resultant. This one is R.
How do we show it, sir, that this is the direction? What do we say, sir?
Yeah, we will find out this. We will find out this angle. Currently, we have not found out the
Okay.
direction. We will find out this angle and we will say let this angle be beta and we will find out this angle. Whatever value of this angle is. Okay. So that angle we will take as the trigonometric ratio. That angle we will
Okay.
take. Right. Now, how to find out this angle? So this angle will be given by, so this angle is given by the formula tan beta. So again, here is a derivation, but we are not going into the derivation of that. We are directly using the formula. Tan beta is equal to, you have to take the opposite. Okay, the vector which is opposite. So let this vector be B. So you write here You write here B sine theta divided by A plus B cos theta. So you have to remember that you have to start from the opposite side. So here tan beta can be calculated as B, that means 20 times of sine 30, sine 60, sorry, 20 times of sine 120 divided by A plus B cos 120. So I hope you will be able to find out this trigonometric ratio. Yes.
Sir, sine 120 is
Hmm. So sine 120
positive.
is sine 60.
180 minus 60 we can take.
Yeah, that is sine 60.
Okay, it's
Okay. So bye everyone. I hope you will do this question and do some more question if you get a similar questions like this.
okay, sir.
Okay. Okay. Bye.
Thank you, sir. Bye, sir.